L&S Machine Company is a small machining shop based out of Latrobe, PA. L&S provides services in machining, welding, inspection, and product improvement. L&S produces about 30 different parts, which can have up to 100 different features per part. L&S mainly produces components for commercial nuclear reactors. Their main customer is Westinghouse, and they supply them with components for commercial nuclear reactors. These parts, which include top and bottom fuel nozzles, springs, and spider components, have to be machined within very strict tolerances. The Haas 3 and 5 axis turning and milling CNC machines that L&S uses are equipped with probes that collect real-time data measurements of the feature being machined at the end of each operation. These features include hole diameters and position, length, and width of slots, XYZ positions of features, and more. After probing, the data is then automatically uploaded to a central database that can be accessed by any computer connected to the L&S server. The database contains an immense amount of data, but it is not being used effectively. Currently, supervisors are able to identify indications of failure after a defect occurs, but they cannot manage the data as parts are being made. The database creates SPC charts and histograms. You can see in this example that the data is trending towards specification limits, but has gone out of tolerance because no one monitors these charts. When the probe finds a feature that is out of tolerance, it stops to alert the operator, who then needs a supervisor to assess the situation. The combination of a defect and machine downtime is the reason why a method needs to be created to help prevent defects from occurring.
The major goal of this project is to develop a method to use the data to prevent features from going out of tolerance. The owner, Rob Donardi, Pam Woodside, and the manufacturing manager, Jason Smathers, suggested to start by looking into the 3 nozzles with the most failures in the past 3 months. They suggested the nozzles because the data collection system is new and the nozzles have the most data collected so far. For the purposes of this project, we focused on the E55. Each nozzle can have hundreds of features with strict customer specifications or tolerances. After understanding how to navigate the database, we exported the data collected for the month of February for several features on the E55 into an Excel spreadsheet in order to begin our analysis. First, we checked to make sure that these features were not time-dependent. In order to do this, we used linear regression and lag-H methods to make sure there was no trend in the data based on time. We did this analysis for 2 of our features to support our assumption that these features are not time-dependent.
Because the data is not time-dependent, we can start to create control charts for various features. From that point, we can calculate plus and minus 1, 2, and 3 sigma levels to form our control chart regions. However, for a process to be considered in control, 99.73% of the data points must fall within this plus minus 3 sigma limit of the mean. If a process does not meet this requirement, an accurate control chart cannot be made. After creating control charts for the correct datasets, a CPK value can be calculated to measure how close a process is running to its specification limits in relation to the natural variability within the process. The CPK value can be calculated using the equation shown. Shown here is an example of a control chart we created with the specification limits on the chart. One can conclude that the CPK value for this process is significantly high because the control limits are well within the spec limits. To monitor the processes through control charts and catch when they are going out of control, various run tests can be performed to take notice of signals that a process is becoming out of control. Some of these various run tests and trends can be seen here. Identifying these trends when they occur will allow operators, supervisors, managers, etc. to catch potential defects before they occur.
At the start of the project, L&S was collecting an abundance of real-time data without a method to effectively utilize it. The team presented a method in which they can effectively monitor the data and prevent defects with examples and validated procedural documents. After the team informed L&S as to how they can use the control charts to monitor their data, owner of L&S, Rob Donardi, sent a letter to the University of Pittsburgh professors demonstrating the project's qualitative improvements. Some final recommendations from the senior design team to L&S include creating control charts for every part using the team's procedural document and CPK training guide. More long-term recommendations include implementing a system to alert supervisors when features begin trending out of tolerance and database improvements to enhance its usability.